If the water pump in your BMW is leaking or making noise, in this tutorial, I will show you the easiest way to replace it. This water pump replacement guide is universal and applies to BMW models with M57 and M47 diesel engines, including the models currently visible on the screen. If you want to avoid leaks and solve all the problems on the first try without additional costs and wasted time, watch the material carefully and until the end. And now, let's get to work. The water pump in my E61 with a 3-litre M57 engine started leaking at the gasket, most likely out of simple old age. I will replace the faulty gasket and the water pump itself because I managed to get a new OE pump for $10, and it would be a shame to leave it sitting on the shelf. First, I remove the engine acoustic cover and set it aside. Next, I unscrew the front bracket panel, a total of 10 Torx screws, and slide the whole thing to the side so that it does not get in the way. Next, I unscrew the plastic radiator fan lock, which is held by 5 screws, and pull this element out, making access to the radiator and the fan. I unplug the connector from the fan controller and from the power supply, doing this quite carefully so as not to yank the wires. I unclip and slide to the side the intake duct at the connection with the anti-shutter valve, because this will allow me to slide out the entire fan panel without any problem, without catching on any element along the way. Now for a small inspection, you can see how wet it is near the pump. On a warm engine, every few seconds a drop of coolant drips from the leaking element, and that means a real risk of overheating the engine, which is why it absolutely must be sealed. I place a pan or a bottle under the car, and now I put a rubber hose onto the end of the coolant drain. I unscrew the cap to drain all the coolant. There will be about 5 litres of it. By tensioning this pulley through the bolt, I release the AC belt, which I can now easily remove without tearing it. By the way, you can check if the tensioner is working properly and if it isn't too loose, because it should sit really tight. In exactly the same way, I loosened the pulley tensioner to remove the serpentine belt, and here a proper lever will be crucial, because everything is very tightly tensioned and you need to use a bit of strength. You can remove it completely or leave it partially wrapped around the pulleys to make putting it back on easier later. Now, I slide a piece of rag or some cardboard under the car so as not to flood my garage, and I unscrew the clamp of the EGR cooler hose, which I unplug completely from the flange. I also disconnect the hose on the other side by the radiator to take it out completely. Here on the screen, you see an additional blue element that won't be there in your car. That's my extra temperature sensor that I used for testing earlier. Next, I unscrew the 2 screws securing the air duct from the airflow sensor and completely remove the element to give myself more space to work. Now, with a little help from a phone, camera, and flashlight, I line up my Allen key with the 4 pump screws and unscrew them to pull out the whole assembly along with the thermostat. Why? Unscrewing the thermostat on its own with such difficult access will take you a lot of time and frustration. So, it is easier to unscrew the entire thing with the pump right away, take it out together, and unscrew the thermostat only later. During the process, a lot of fluid will appear under the car, because until now it was blocked inside the engine by the pump and the closed thermostat, and unfortunately, it can no longer be salvaged. It just has to drain down the engine block. Before removing the components, I disconnect the thermostat from the rest of the cooling system, and now, slowly and carefully, I separate the pump from the engine block, making sure not to hit anything, especially the radiator fins. As soon as I manage to detach it, I pull the whole assembly out using the free space on the left side. After removing the water pump, the entire surface on the engine block looks more or less like this. Everything is dirty, greasy, and the gasket is still sitting rigidly in its place, refusing to come out without using force. After removing it, the cast iron itself looks like this, but we will fix this state of affairs in a moment so that it never leaks from this spot again. The old gasket and the old pump don't look the best. It's clear their glory days are long behind them. The pump still works, and generally everything is fine with it, but I managed to buy a new water pump with the same part numbers second-hand for $10. So to avoid coming back to this repair in another year or two, I'll replace it right away and I'll have the whole cooling system sorted out for years. I've already bought a new gasket, the same as the previous one, with the same markings matching this specific model. But you should know here that fitting such a gasket in a way that achieves full sealing is very difficult, and you really need a lot of experience to do it right. Even I don't succeed sometimes, which is why here I will show you an easier option using Dirko silicone instead of the metal gasket. And I will record a separate episode about the metal gasket so that you can choose between the two options. There are a few things that aren't entirely obvious and can completely ruin the final result. This is one of the most difficult installations because it's greasy, damp and dirty. Dirko is a liquid gasket resistant to temperatures and petroleum-based products, which will work perfectly fine in this spot. First of all, after removing the part you want to seal later, you must prepare the surface for the silicone, meaning you need to thoroughly clean away all the dirt that might have collected there. On the surface intended for the new gasket, there cannot be any carbon buildup, burnt oil, old adhesive, or remnants of the previous gasket. Everything must be removed. The better we do this, the greater the durability of the new seal we apply. The second extremely important thing. After cleaning away all the grime, the surface to which we will be applying the gasket needs to be degreased very thoroughly. If the surface on which we want to apply the silicone is greasy, it simply won't stick at all, or it will stick very poorly, which means the connection might not be tight. The same applies to the component we are going to seal. Its surface must also be cleaned and degreased. What kind of product should you use? There are many products on the market, but I personally use a silicone remover or a brake cleaner because the price is very good and the excess product evaporates very quickly. Now for the specifics regarding the application of the product, the first practical pro tip. I squeeze a little bit out onto a piece of cardboard and set it aside. This will be our control sample, which we can come back to after some time to check if the compound has fully hardened. Based on that, we'll know when it's safe to work on the car with oil or coolant so that we don't wash it away. When it comes to the actual application of the product, I do it very slowly, making sure to evenly cover every edge with no empty spots and without squeezing out too much. The most important thing is not to overdo the amount. It might seem surprising and counterintuitive, but in this case, more is actually worse. If you apply too much silicone, once the components are fitted and the bolts are tightened, all that excess will squeeze out from every possible side as the parts are properly pressed together, which creates a very serious risk of complications. If there is too much of this silicone hanging off the sides, all those protruding bits can break off over time and clog things like the radiator channels, or get stuck in the oil pump, or in any other tight spaces, and we must avoid this situation at all costs. Seriously, for this kind of seal, a layer literally 1 to a maximum of 2 mm wide for wide elements is enough, as long as it's applied evenly and is continuous. Before you apply the silicone to every nook and cranny that needs it, please leave a like and subscribe to this channel. It really helps in growing the channel. Thanks! Now, for the second very important point, and this is the stage where most people make a mistake. If you have already covered the entire component, do not install it right away. It is very important to wait for about 10 minutes to let the compound catch a bit of air and moisture. If you don't do this and bolt the parts together immediately, the curing process will take much longer, and starting the car too soon could cause the gasket to blow out. So, as not to waste time while waiting, it's a good idea to clean out the mounting bolt holes. In my case, clearing them of any excess coolant that might have leaked inside, because water in those holes will mean we won't be able to tighten the bolts all the way and the pump won't seat properly. After waiting 15 minutes, we've reached the final and most important stage, after which I will also show you the final result. Now, I carefully put the pump in its proper place, being careful not to let the silicone touch any other component. I apply the entire part as flush to the surface as possible, aligning it directly with the bolt holes beforehand so that there's no need to rotate the pump at all once it touches the engine block. This takes a bit of practice, and honestly, I had my doubts about whether I managed to do it right the first time, which is why I took everything off again, cleaned it, and reapplied it all over. If you're working in such a hard-to-reach spot, it's a good idea to ask someone to help with a phone, as the extra screen expands your field of view a bit and makes putting the bolts in much easier. This way, you can also make sure that everything has seated properly and fits together as it should. I tighten all the bolts to the manufacturer's recommended torque and leave the component to dry completely. According to the information on the leaflet, you should wait an hour for the element to start sealing. But honestly, I checked it myself after an hour, and everything was still wet. Which is why, if you can, leave everything overnight so that the compound can gain its full flexibility, just like you see on the screen right now. Then everything will definitely be great. The final result looks as follows. Even though I applied quite a small amount of silicone, some of it still squeezed out the sides, and generally with the amount you see now, there is no need to worry. The entire compound is very flexible and cohesive, And as long as we don't try to touch up anything ourselves by tearing or cutting it off, everything will hold up and work perfectly. A potential problem may arise when what's squeezed out the sides is much more than what you see here. In such a situation, you must sensibly judge whether to leave it as it is, risking some of the bits breaking off, or if it's better to take it off and redo everything from scratch, applying even less than before. If it didn't work out the first time, don't worry, you will definitely succeed the second time. Experience is gained over time. I am now unscrewing the thermostat from my old water pump and taking a moment to clean it and check if all the gaskets look as they should. The entire component is 6 months old and looks great. I see no reasons not to reinstall it back in its place. I lubricate the edges of the flange and the gasket with a bit of fresh coolant, having previously disconnected the hose that was dangling on the other side. Additional lubrication of the gasket will allow us to fit the flange under the EGR cooler more easily. After the thermostat clicks into place, I secure the flange with a retaining clip so that nothing shifts on its own, and I put all the screws back into their places. There is a bit of a tight space here. If you have trouble lining up with the holes, you can always use the phone trick just like we did earlier. I tighten the thermostat with a torque wrench set to 10 Newton meters. Next, I put the second water union back into its place, securing it with a retaining clip on both sides. Access is easy, so you shouldn't have any problems with this. At the very end, just the smallest hose from the EGR cooler, and we have all the components related to the water flow out of the way. The system is now closed. I am now filling the entire cooling system with the appropriate coolant and checking all connections thoroughly to make sure I haven't forgotten anything and that there are no leaks anywhere. At this stage, when the radiator fan is not yet installed, it is much easier to verify this. If you have the opportunity to get under the car, this is the best time to do it. If everything is fine, I put the air intake duct back in its place, starting with positioning the lower part, and then I tighten both screws near the mass airflow sensor, and next, using exactly the same system we used to remove the serpentine belt, we will put it back in its place. I pull back the pulley responsible for tensioning the whole belt and try to position it properly. The belt is quite stiff, so it might be a bit harder for you the first time, but at some point, everything will click perfectly into place. Putting the second belt on is a breeze. Easy access and only 2 pulleys. Right after that, I drop in the radiator fan, making sure that it correctly clicks into its guides on the right and left sides, and I also connect both electrical plugs, trying not to bend those wires too much. Immediately after that, I put the intake duct back in its place near the throttle body, and at the very end, all that's left is to screw on the plastic radiator shroud elements and the front bracket, which you will definitely have no problem with. The final and most important element that cannot be skipped is properly bleeding the entire cooling system. If you don't do this according to the 3-step instructions, the water vapor pressure will blow out the gasket at the weakest point. You can find the entire bleeding procedure in a separate recording, which I warmly invite you to watch. Good luck!